Hello, my name is William Huang, and firstly, I'd like to thank you so much for taking the time out of your day to look at this video during this tough time. Secondly, I'd like to apologize for my computer setup. I know it's not the best, but I was not able to grab the best microphone setup before the coronavirus pandemic began. So I apologize if this sounds like hot garbage, but enough about that. For my ISM project, I've been studying machine learning for the past year because of my fascination with artificial intelligence. Not only is it the coolest thing for a computer science scientist to do, in my opinion, it's an innovative field that has grown so rapidly in less than a decade and has made its applications to the world known in so many ways that a world without them can no longer be conceived of in this modern technology age. For my presentation, I plan to introduce what the ISM program means to accomplish with its students, present my research into machine learning that I've been delving into for the past year, and follow my product's development in machine learning. First off, ISM is made of three main parts that each have their own meaning and make up the whole of ISM. The first part, I, stands for independent, which describes the workflow and your topic selection. Because you get to select your own topic, the class is unlike any other. And the curriculum that each student kind of assigns themselves is also unlike any other. There is no concrete curriculum for each student, aside from progress checkpoints. But other than that, how you go about tackling each problem you face is largely on you. So my topic is machine learning, but in my class, there are many varieties of topics. For example, we have one student who is going into the veterinarian field. We have someone who is a tattoo artist, and we have someone who is going into trauma surgery. There is a whole mosaic of things that you could be in ISM. The second part is study, which describes the research of the selected topic and the making of a new product. You spend your years studying the topic, going through scientific papers or interviews and other primary sources to gain a basis of understanding that for what makes the field tick, what are its problems. And then you find a product idea that you developed to solve those issues in the field, improving it and making a lasting contribution to the field. ISM provides assistance in your presentation through Toastmasters, a program that helped me personally get over my public speaking anxieties. Periodically, we would be assigned a role in giving speeches on various topics to give each other in the class, and it all helped me to practice for this very moment. The last part of ISM is mentorship. In the studying process, a professional in the field, usually outside of the school, acts as a guide for your topic to help you navigate through it and create the finished product. They are people who are with you the whole way and should be people who are willing to teach you. In my case, my mentor was Owen Huang, a person I had contacted in the company that I had internship over the summer. He is a Duke graduate student and CEO of Grade 8 Health, the company that I mentioned that's working on ways to implement machine learning research into medical applications. Because of our circumstances, the majority of routine mentor meetings we had throughout the year for ISM took place online. Meetings would generally consist of me asking questions I had and Owen guiding me to the right places to look, often leading me to find published scientific papers and experimenting with code. I had added bonus for these nature meetings as they were not as effective during the pandemic. So I was able to more effectively work on my product. Let's delve into what my topic actually is. For those of you who don't know, the term machine learning refers to a computer's ability to train on a data set to make predictions that are not explicitly coded in. In other words, it's an artificial intelligence. Its applications, different types of models, and the optimization of machine learning is what I have researched over the year. I feel that machine learning in general has developed under the radar for most people, but any professional website or service or tech business, as you can see here, all of these are companies that have implemented machine learning at least to some degree. And these are just a few of the examples. Now, you can try a simple machine learning program at home using these apps. For iOS, the app is called iDetector. It allows you to do a simple object detector using the Cocoa dataset. And for Android, it is called Object Detector. Both of these are trained on the Cocoa dataset, which stands for Common Objects, that allow you to just point the camera at any common object, say a computer monitor or say a bottle, a table, a person, a chair, anything. And it should be able to, with high enough confidence, be able to identify that object as an object. So why do I want to get into the scene now? Many of the resources that are available today in the machine learning environment are super useful and make it very easy for someone like me to get into the field. Data sets and competition programs like ImageNet and Kaggle and many other data sets made of a variety of objects. Namely, ImageNet and Kaggle are the important tools, though. Both are websites that encourage competitions and collect data sets for people to judge, challenge, and even win prize money in. These programs functioned as engines that have driven innovation in machine learning. Now, how machine learning actually works is that it looks like this. It's a little messy, but for now, let's just focus on this part. How it works is that pixel values in an image are observed and recorded, but in a neural network. Each of these neurons, these little circle bits, are representative of a feature that the image has that factors into an answer. In this example here, with a simple model made to identify numbers, features like, say, curves or straight lines could be stored inside these neurons, learned in training, and eventually used to output their answer. These were known as perceptrons and were simple object identifiers back in the day. But the rest of the neural network that I had blocked out was developed in more recent years, and it helps the network more easily identify all those important features. In fact, as of 2015, because of these innovations, machine learning models have surpassed human beings in object identification and continues to prove to this day. The implication being that computers are getting so incredibly good at pattern recognition, so much so that they could possibly find new patterns to identify objects by, and better than any one human being could do. So here is an example of what object identification or classification looks like. The computer here has been given a list of options and is given an image as an input. It then outputs what its decision is and what it believes is the image based on previous training. The level above object identification is object detection, where not only is it trained to classify what that object is, it is also trained to show where it is, which is adding a localization to the output. You see, there's a bounding box around objects that is able to identify. Recent models like YOLO v3 has even allowed the detection to happen so quickly that you can record it in real time, as you can see here, and as you can see in the previous app that I had mentioned before. Another level up is called object segmentation, where the output includes every single pixel of importance that makes up the object, allowing the model to mask an image and define its position relative to other pixels, making it a more precise form of classification than bounding boxes. The most interesting part of machine learning applications is in the medical field, I believe. Here we see a utilization of object detectors to see a possible lesion or abnormal growth on the lung CT scan, which leads into what I want my final product to be. I wanted to create an application that uses machine learning to solve a medical identification issue, identify pneumothorax from an X-ray scan, a condition that fills the chest cavity with air and displaces space in the lungs. The first step for that was to get familiar with TensorFlow libraries, which is used to code machine learning and how it manages image segmentation. Luckily, TensorFlow provides an ample guideline to help me create a working example model. Here we can see the model is quickly training itself in image segmentation on a data set for cats and dogs. In this example, we only have cats. The next step was how to use and manipulate large data sets from Kaggle, because I had planned to use data from Kaggle for this product. For this step, I used a data set that used ultrasound images on nerves inside the neck as another stepping stone in the process of creating a data pipeline. Since it would be my first time creating one, and if I had learned to do it in this step, I would be able to transfer that knowledge to the harder data set like lung segmentation. So once I had learned to do that, finally I was ready to move on to the X-rays of lungs and implementing pneumothorax masks. It's a little difficult to see here, but in these small shaded sections, you can see that the pneumothorax mask has been overlaid onto the chest X-ray. My product at this point was ready to begin training and make its own mask predictions. However, there were some issues that arise that I'll get into later. finally, for my final product, it ended up being a segmentation fully of lungs. As you can see here, these are the results from my training. They are all able to pretty effectively and accurately show which parts of the chest X-ray represent the lungs. However, it is better if I just show you how the final product looks right now. So here is my Colab notebook that contains my final product. Colab is a program that allows you to create computer programs and use Google's servers Google's GPUs to run machine learning programs. This makes it, cost efficient and it's free, and so it's what I've used to, manage all of my programs. So here we have my final product. You can see that I've already run some of the cells to save time, and I've also uploaded the necessary folders that are all available on my GitHub. Here we have the pneumothorax example dataset. I use this to show how my computer model will basically how my computer model will identify the lungs in each patient. So here we're loading our dependencies, we're defining how to read each lung mask when we get them. Here we give the labels and all the file names, and then we allow it to process all those file names to create one data set. That data set, as mentioned before, is using a mapping technique that allows multiple images and masks to be processed at the same time, allowing it to the Colab notebook not to crash and is more efficient and a lot faster. In another notebook that I have already trained this model to look at lungs. So here we have the loaded model data set that has already been trained so that we don't have to wait. And if we run this cell, we can see a couple examples of people with lung problems and how the machine learning program decides to identify it. Now, as you can see, it does seem to have a couple issues still. There are a few artifacts that are, laid about outside of where the lungs, typically are. But for the most part, there is a clean outline for a majority of the lung. And if we were to continue looking through these images, we should be able to see more examples of people with perhaps pneumothorax. And the great thing about my product is that even if we have these artifacts that reside here, we can continue to improve the model because this is all available on GitHub and it's all available on my own program. And the training does not take that long. I can continue to train it and add on to the loaded model so that in later versions of this final product, I can have an even more accurate reading of the lungs. So here are a couple of the roadblocks that I mentioned before that I ran into while I worked on the product. The first problem was what type of model to use. There are a variety of models to implement in the machine learning community, all of them with their, comparative accuracies and, advantages, disadvantages. The way I solved this problem was by implementing multiple models on the dataset training and comparing all of their accuracies at the end to see which one was objectively the best one to apply to my dataset. The next problem was timing and the memory limitation. So training on the example dataset with the cat and dog dataset could take up to about at most a minute, a couple minutes. But going into the larger medical dataset, I had noticed through the same process, the training would take up to 10 hours. Such a long time to do training was unreasonable. And this was because they were, well, one, larger data sets in both quantity and resolution. So this was solved using a resizing option that would sacrifice some resolution in exchange for a more bearable training time that was similar to the example data set, back to a couple minutes, other than aside from instead of hours. The last problem was memory limitations, GPU restrictions on Google Colab, and how I was handling the data, processing each image one by one, causes the notebook to crash due to all the memory being used up. And this was solved with some guidance by my mentor, who had taught me and guided me to using the mapping function that would allow me to more efficiently process my data multiple images at a time. That way, I was utilizing and I was restructuring the data pipeline to use less memory and make the model usable and more efficient. I'd like to take this time now to say how grateful I am to my mentor, Owen, every step along the way. The guidance you provided in my education is absolutely irreplaceable. I really could not have created this product without you. Thank you so much for taking the time to, answer any questions I had, even if they were, like at 1 a.m. and, really dumb. Thank you so much. Because of the format of YouTube, I'll be active to answer any questions in the comment section below. So let me know if I can elaborate on the subject outside of this presentation. Thank you so much for taking the time to watch this.